We're on page 581, slope point form of an equation. So at the top of this page, they write it out for you. So we have y minus y1 equals m, and in brackets, x minus x1. So what's really important to note about slope point form is you would replace y1 and x1 with a point. So that represents like a set of coordinates. I would write this down, guys. So for slope point form, you require a point. As well as obviously m is still representing our slope. If you think about it, y equals mx plus b, or slope intercept form, we require a slope, same thing. B is our y-intercept, which is technically a point, right? So they're very similar that way, but ever so slightly different. So we'll go through it, but this is just another way to write an equation. Because this one isn't just y equals a bunch of numbers, you can't just plug it into your calculator, right? Because your calculator is formatted that it's always y equals something. In this case, it's going to be like y minus 3 equals something. That being said, this unit we are going to do without a calculator, and so you wouldn't need to do that anyways, but just so you're aware. So let's go through their first example. So state an equation in slope point form. So you're having to remember the difference between the two, given a point with the slope. So this is my set of coordinates, and then 3 is my slope. I don't know what this thing is on the screen. So our general equation is y minus y1 equals m times x minus x1. Well, all you're going to literally do is replace those values. So I'm going to replace y1 with the 5. I'm going to replace my slope with the number 3, and then I have x minus 6. So your y and x, those stay the same. Just like in our slope intercept form, like y and x were still there, we still have y and x here. It's just like rearranged differently. That's the only difference between this form and our other form. And I'll go through an example where we convert between the two. But we're just seeing a different format to write it in. Make sure when you're plugging it in, the most common mistake when plugging them in is to plug in x and wrong, like opposite. So in this next one, so we have x and then y. So when you fill this in, I don't expect you guys to write out your general form. Like on a question like this, you could just go straight to your answer, but because we're just learning it, I'm going to write it out. I'm going to replace y1 with -1. When I subtract a negative, we're adding. So we'll have to simplify that afterwards. So the -4 goes here, x minus 1. So your final answer on this one is actually y plus 1 equals -4, x minus 1. Go ahead, Khalil.
You know, you just said your equations like this, just in case, what is the x and the y of the y1 and x1? Like, where's it supposed to represent?
It's just another set of points. So it's saying we could plug in any point at that for those two. So here, really, it's talking about two different sets of points, x and y, and then like x1 and y1.
So it's like rise or run times slope equals rise.
Kind of, yeah. Yeah. That's a good way to think of it. Be really careful with integers. They come into play a lot. That's one of the reasons as well why we're taking your calculators away, is forcing you to remember your integer rules. Okay, so this one, I have 2 negatives. I'm going to write just to the side so that I can write a little bit bigger. My general formula has subtraction in it. So y1 is -8, so I'm subtracting -8. My slope is 1/2. And then I get minus -9. When I subtract a negative, that becomes addition. So it becomes y plus 8 equals 1/2 x plus 9. If you can go directly to that last line, that's totally fine for me. You don't have to show a lot of work. This question would be like a 1-2 question. So you don't have to show a lot of work there. Is that okay? Cool. So this is where this next one, I'm going to show you how the two different formats relate to each other. Oh, sorry, Khalil.
Just checking for them, like the y1 and the x. Do those coordinates, are they then both positive, or is it like that we have to when we're going back to try to see the coordinates in that form, we would have to convert them both to positive?
It's going to depend on the points. Like the point I plugged in was a negative point, but part of my formula is this first chunk, right? Like that's a set piece. So in this case, they both became positives because I subtracted a negative, but it's very situational.
But there's, on the graph, they're still both negative.
Yes. Yes, I see what you're saying. Okay, so in this next one, they give us our slope of m equals 5 and a point at -5 and 2. So if you wanted to plug this into your calculator, let's say you'd solve for y. So let's go through that whole process. So first, let's plug it into our equation because it tells us we're going to use slope point form. So we're doing our y minus y, x minus x, plugging it in. So we get y minus 2 is equal to 5x minus -5. I'm really showing a lot of work here, but you guys can show as much or as little as you need. So then this becomes 5, and then x, my pen stopped writing. No. Okay, we'll just start over. My apologies, guys. There we go. Oh no. Okay. So then I'm just going to simplify that. So I get y minus 2 equals 5x plus 5. So to convert this to slope-intercept form, which is what our question is asking us really to do, you have to distribute this 5 to both of these pieces using our distributive property. You have to do that first. So then I get 5x plus 25. We have to do that first with like our basic solving for y properties, right? Like our basic algebra properties. You do like the math that you can do first. We're going to do our multiplication, and then I'm going to add 2 to both sides. So then I would get y equals 5x plus 27. So what's really neat here, I mean neat for math, this equation and this equation, while they look completely different or fairly different, maybe not completely, they will graph the exact same line. So if you were to, like, if I gave you like a Cartesian plane and got you to plot these points and to count out your slope, you would get the exact same line for both of these. It's just 2 different ways to represent the same line. Both of these have a slope at, like from here, you can tell a couple pieces of information that our slope is 5. We have a point at -5 and 2, and then our y-intercept is going to be at 27 or 0.27 if you want to think of it that way. So we actually know 2 points and our slope from those 2 equations. Same information, just represented in 2 different ways. Okay, let's try this next one. So we're going to do that same process again. So y minus y is equal to m x minus x. So I get y minus 4 is equal to -7 x minus -7. So whenever you have a negative with this formula, it's going to end up being positive. So I'm going to get x plus 7. And then from here, we're going to change it to slope-intercept form, or y equals mx plus b. So I distribute that -7 through. Yeah, I changed my 3 to a 7. You guys didn't pick up on that? At least I kept the negative sign though. That's a 3, so then it becomes x plus 3. Thank you. So I get -7 times x, that gives me -7x. -7 times a positive 3 gives us back to a -21. Now I have to add 4 to both sides. So then I get y equals -7x. Okay, let's think a little bit. -21 plus 4, so we're getting less negative here. Brings us to -17. So again, if you were to graph these, this equation and this equation are going to graph the exact same line. Does that make sense? Slope intercept form, so y equals mx plus b, is the most useful by far. It's the most common and easiest to kind of work with. Slope point form, which is what this form is your next most helpful when it comes to graphing. Okay, so let's read through this next kind of situational one. John and Nikki were solving the following quiz question. So determine, oh, we can't do this yet. Never, okay. Determine the equation in general form. So that's the type we're going to learn about tomorrow, but we don't really need it here. Of a line with a slope of -2. So I would write down m equals -2. Do you have to do that? No, but it's just a strategy to help you. Passing through a point at 3 and -5. John could only remember slope y-intercept form. So he only remembers y equals mx plus b. He's not a great student. Nikki remembers slope point form. Y minus y equals mx minus x. Complete their work, which is stated below. So let's just finish with what they're doing. So if we look at John, he was like, okay, I remember this equation. I'm going to work with what I have. So he was like, I remember, the question told us my slope is equal to -2. And that we also have a point. What was the point at? 3 and -5. So he went, I was like, I'm going to plug in that point into my x and y. So he took that point and put it into here. Is he allowed to do that? Totally. There's nothing wrong with that. Our general form always has the x and y still there. But by doing that, he's able to isolate and solve for b to find that piece of information. So let's figure out what b is from here. So then he's going to keep going and finish this out. So -2 times 3 gives us -6 plus b. So then if we add 6 to both sides, we find our y-intercept is at 1. So then he would have gone and plugged that back into his original equation and gotten this. So John, while I said he wasn't a great student because he couldn't remember general form, which you guys don't know yet, he still was able to manipulate this and write an equation down. So he used what he remembered to his advantage. So maybe he's smarter than we originally thought. Nikki, on the other hand, remembered slope point form. So then Nikki went through, replaced our slope, and then replaced our point at at 3 and -5. So let's go through Nikki's and solve and isolate for y. So here we would have 2 negatives, so we're going to write this to be y plus 5 is equal to, and I'm going to distribute this 2 through. So I get -2x plus 6. To solve for y here, subtract 5 on both sides, and we get that same equation. So they only had a partial memory, but they were able to get still there. Right, so a lot of questions in this unit, you can use different approaches to get there, which is kind of nice. Turn the page. So I'm going to change this question, and that's because I skipped lesson 3. But basically, if you're given this graph, let's write the equation in slope point form. So to do so, the first thing you need to do is find your slope. Then you're going to pick a point. So this is the process you would use, and then you'll use your equation. I want you all to find out your slope here. Try and count it out on your own. So make sure when you're picking your points to count from, you're choosing 2 points that are at perfect coordinates, so that are at like not partially between. So here my y-intercept is at a decimal point. So don't choose that. So I chose 2 that were fairly far apart, and I got a slope of -3/4. Raise your hand if you got -3/4. Awesome. If you chose 2 different points than me, would you still get -3/4? Yes, awesome. Okay, so now you're going to pick a point. With slope point form, you can have a lot of different equations that are equivalent. So if I chose, just for convenience sake, the first point that I picked here, this is at -5 and -1. I can choose any point on this graph. So there's a lot of correct answers, but that's going to be my point. Do you have to show this much work? No. But I just want to make it really clear. So that's the point I'm choosing, but you could have chosen any point. Go ahead, Khalil. Could I have, is it at a perfect? Yes, you could have. Only because it's like at a perfect whole numbers. So then I'm going to plug it in. So here's my equation. So then I get y minus, in this case, -1 equals -3/4 x minus -5. I have to simplify it. If you don't simplify it, I'm taking marks away from you. So I get -3/4 x plus 5. I really want to stress this with you guys though. If you chose a different point, your answer still can be correct. It'll look vastly different, and that's just fine. Makes marking just that much harder for me, because every single person here could have a different point and still be correct. Okay, so this, on this question, like this final line here is your final answer. I showed a lot more work here. You could have shown much, much less. Okay, let's look at this last example. So we need to state the slope of our line and then write the coordinates of a point. So it's asking us to like work backwards from how we originally started. So on A, what is my slope? Go ahead, Khalil. Why negative? Okay, 1/7, good. Our point, you have to be careful with the point when you're reading it. Because negative is in the formula, it's actually a +4. But because this is a positive sign, it had to have come from a -11. So it's kind of opposites there. So you have to make sure, right? Because before this would have said y minus -11 for that to become a positive. So the actual coordinate you have to be thinking about there. On B, my slope. Jacob, what's my slope for B? You have your workbook right in front of you. Yes, you're totally right. -5/3. Good. My point, Audrey, what's my point? No. So remember, the negative is like part of the formula, so you can just ignore it. So we're just looking at the 7 and 9. So which is my x? 7. So we get 7 and 9 is our point. It's tricky, and it's like something you really have to think through. Okay, let's look at C. Drew, what's my slope? Good. Priscilla, what's my point? Good, +6 and 0. So there's nothing over here, it's just y, which means before that it was y plus 0. Right? We don't have to actually write +0 down, so that's how we know that. Our last one is in slope intercept form, but we still know our slope is -3. And then our point is actually our y-intercept. So we know that this point is at 0 and -6, because that's our y-intercept. So that was a very subtle change that's really easy to like trick with you, right? The difference between C and D is this one still had this brackets here telling us it was in slope point form versus no brackets on this one, having distributed like that 3 through effectively, put it into slope intercept form, which told us then that that was our y-intercept. So this unit, there's lots of little things like that that makes it more difficult and harder to like, easier to make little mistakes with. Okay, for our next like set of practice questions, I typed them up for you guys so you have like a paper copy, and I added some of my own ones in just because I felt like I wanted you to hand something in here. So I'm going to hand out those for your practice questions. It's basically your workbook, but just on a piece of loose leaf.